All right, so let's quickly check homework for today. Questions on 1 through 6. Any questions on the ones that are up there right now? Okay, there's ones at the bottom. All right, we're going to be doing lesson 8.4. So if you don't have questions on homework, we'll go ahead and jump into that. We're going to continue doing Trig. So this is, today is word problems with Trig. I have a little helicopter I'm going to use on this last problem. So if you want to draw your own helicopter, feel free. I am terrible at drawing them, so I just went and copied and pasted a helicopter. It's the very last problem, so we're not going to be there yet. Okay, so lesson 8.4 is going to be more trigonometry. So these are applications, meaning word problems, where you get to use what you've learned about how to set up equations to solve for sides or angle measures in a right triangle. So first of all, some terminology. You might have heard this before, like for example, maybe in physics, if you've had physics or any kind of similar type of science problem. An angle of elevation means that, like how this guy is elevating his leg, elevating his foot, it means that if you were to look at the horizontal and raise your eyes up, that forms an angle of elevation. Okay, angle of elevation is the angle formed between a horizontal line, always from the horizontal. Okay, between a horizontal line and an observer's line of sight to an object above the observer. Elevation means to raise, right? So if you were to look at straight out horizontally and then lift your eyes, you're creating an angle of elevation. When a plane takes off, the angle at which it's taking off is called an angle of elevation. Okay, it would be that angle right there. Or even if you wanted to pull it down to where the ground is, you know, measured from the horizontal against the ground, these angles would be the same because they're corresponding. So whichever way you kind of like to see that picture, that's the angle of elevation. So an angle of elevation is, again, always from the horizontal going up. Horizontal up, horizontal up. Never from the vertical, always from the horizontal. And then an angle of depression is an angle that's formed between an observer's line of sight and, again, the horizontal, but raising lowering your eyes down. So angle of depression is the angle formed between still a horizontal line and an observer's line of sight, but this time the object will be below the observer. Okay, depression means to lower. So elevation, we're going above from the horizontal, looking straight out, raising your eyes up. And for depression, you're looking straight out and then dropping your eyes down to something lower. So for example, on an athletic field, so on the football field here, there's a guy who's standing on the field waving up at people in the stands. The angle of elevation at which he sees that person in the stands, okay, from the horizontal up, that angle of elevation right there is the same as the angle of depression of the person who is up here in the stands. So if this person is up here and drops their eyes down, that angle right there will be congruent to the angle of elevation. So whether the person's down below looking up or whether the person's up high looking down, if both of their angles are measured between the horizontal and their line of sight, those angles will be congruent. Why does it make sense in that picture that those two angles should be congruent? Why does it make sense?
Because they're alternate interior angles.
Alternate interior angles. So we know that the lines are parallel because why?
Because they have to be horizontal.
Yeah, theoretically they're parallel because they're both from the horizontal. Now we know that when we're talking about real life here, nothing is going to be exactly horizontal, exactly vertical. So everything that we do with the word problems is a little bit, you know, of an estimation or like best case scenario, you know, type of thing. Horizontal lines are parallel, so the angle of elevation, angle of depression should be the same. Because if parallel lines are cut by transversal, then alternate interior angles are congruent. Okay, so in this picture, mark a 30-degree angle of elevation on the diagram. So if you were down here and looking horizontally, and then you raised your eyes up, you know, it might be someone on the ground looking up at their cat in a tree. It might be someone on the, like a firefighter on the ground looking up at someone in a burning building. It might be someone on the ground looking up at a person who's on the top of a building. Okay, angle of elevation is going to be from the horizontal going up. So this would be your 30-degree angle of elevation. Okay, for the 50-degree angle of depression, how would I draw that? Mark a 50-degree angle of depression. How do I show an angle of depression there?
Do you have to make another horizontal line that's parallel to the base?
Yes.
Or I guess to the bottom?
Yeah, so where will
and then you would, yeah, and then your angle of depression would be from the horizontal line. It would be the angle where the horizontal line meets the hypotenuse.
So it's actually outside of the triangle, right? This is a little weird at first, but an angle of depression, remember, is supposed to be congruent to the angle of elevation. So if you're, again, up here looking down at something below you, your angle of depression is formed by looking horizontally and then dropping your eyes down. Okay, so if this person were to look out and then drop their eyes down, it's the angle that's formed right there. So this is the angle of depression, and it said 50, I think, right? So that would be a 50-degree angle of depression. It has to be congruent to the angle of elevation. So this would also be a 50-degree angle, but that's not an angle of depression, that's angle of elevation. What would be the measure of the angle inside of here? As someone who has not answered a question yet today.
It would be 40
Why, Madeline?
because it's complementary to the angle of elevation.
Right. So we know that in the triangle here, they have to add to 180, right? So we know that these two angles are complementary. We also know that because this would be a vertical and that would be a horizontal, this will be a 90-degree angle up here. So force that one to be 40. Okay, so the angle of depression they asked you for is that 50 degrees out there. But just keep in mind, you actually do know all the angles inside the triangle if you know an angle of depression like that. Okay, and then for this one, angle of elevation or angle of depression. So you've got a person on the ground looking up at the top of a tree. That makes that an angle of elevation. And then for the other one, this person, you know, they might be like on the beach looking down at somebody in the water. They might be on a mountain looking down at someone in a valley. Okay, so it's always going to be like from the higher looking down below. So it's this angle right here would be an angle of depression. Okay, so we've got 3 word problems here. Again, these situations, we're going to assume that like things that look like a horizontal and a vertical are going to be perpendicular. Sometimes in real life, like buildings are not 100% vertical, right? Or trees are not 100% vertical, but we kind of simplify things a little bit in order for the trig to make sense. So we just have to kind of acknowledge that really we're approximating like through the whole situation here. The angle of elevation from point A to the top of the hill is 49 degrees. Okay, so here's the hill. It says that the angle of elevation from point A to the top of the hill, and then I'm going to drop the vertical here so we can have our right triangle there. Okay, the angle of elevation from point A to the top of the hill is 49 degrees. So that 49 degrees goes where in the diagram? Andrew, where does the 49 degrees get placed?
Would it be by the A?
Yeah, down by the A.
Or wait, yeah.
49 degrees would be the angle of elevation. So from the horizontal up is 49 degrees. Point A is 400 feet from the base of the hill. Okay, Brooke, where does the 400 go?
Would it be from point A to the right angle,
Okay, from point
like at the bottom?
the bottom. From point A to the right angle, that's the distance from A to the base of the hill. It just means the bottom of the hill. Okay, how high is the hill? So that means our variable is going to go over here. All right, Daniel, tell me, is it sine, cosine, or tangent?
Tangent.
What will the equation be? Tangent of what?
Tangent 49 equals x over 400.
Over 400. Okay, Sam, if you were going to solve that, what would you do next?
I multiply the tangent and then 49 degrees by 400.
So we're multiplying full size equation by 400 and then typing that in the calculator. So 400 tangent 49. Now on these problems, I'm going to try to tell you what to round to. If it doesn't say what to round to, then you just kind of do what you think makes the most sense. I try to tell you what I want it to round to, what I want it rounded to. Sometimes it'll be at the top of a group of problems. It'll give you directions for the whole thing. Sometimes each individual problem, it might say round to the nearest whatever. So to the nearest foot, that's going to be 460 feet. And I'm going to write approximately because, again, this is an approximation. X is approximately 460 feet. All right, the next problem. Leah is meeting friends at the castle in the center of an amusement park. You can probably think of an amusement park that has a castle in the center. I'm going to draw a very simple looking castle that is like this kind of situation. Okay, maybe there's a doesn't like my curves today. Maybe there's like a little flag on the top or something. Okay, there's my castle. Lovely, isn't it? All right, Leah is meeting friends at the castle in the center of amusement park. She sights the top of the castle at an angle of 38 degrees. So here's Leah. Leah is purple. Okay, and she is looking up at the top of the castle. Okay, and it says that the castle is 190 feet tall. So that means that this distance is 190 feet. Okay, and she is 5.5 feet tall. So this distance right there is 5.5 feet. The distance from the castle, from her distance from the castle is what we're looking for. So here would be the rest of your right triangle. Okay, so tell me where the variable goes. Tell me where the variable goes.
It goes on the adjacent leg of the.
Okay, so we're looking for that distance, right? Okay, Solly, can you tell me where, how to use the 5.5?
You can use the 5.5 to you can use it to determine the height of the I can't even think right now. I remember doing this. Use the 5.5 to.
So sometimes when we do these problems, we will take the angle of elevation off of the ground. So even though we know that a person's line of sight would come from their eyes, sometimes we ignore their height, we just go from the ground. But on this problem, instead of saying the angle of elevation is coming from here and going up, okay, where this side of the triangle would be 190, we're coming off of her eyes. So how does that affect this side of the triangle over here?
You can use the 5.5 to reduce from 190.
So this side of the triangle is actually going to be 190 subtracted by 5.5. So that side of the triangle is actually 184.5 feet. So you don't want to use the 190 on this one because the triangle is actually coming off of her head rather than off of her feet, rather than off of the ground. Okay, so we have that 184.5. What have we not used? Bronson, what have we not used that was given in the problem?
We haven't used the angle measure.
Where does it go?
Sorry.
Where does the angle measure go? So it's 38 degrees angle of elevation. Where do I put that?
You would put it at her line of sight. So the hypotenuse in X.
Angle of elevation would go right there. Okay, so I'm going to turn this down a little bit so I can learn to work my beautiful drawing. Meg,
Yeah.
tell me, is it sine, cosine, or tangent? Sine, cosine, or tangent? We've got 38 degrees, we've got X, and we've got this side over here is 184.5. Sine, cosine, or tangent?
Tan.
Okay, tell me the equation. Tangent of
38 equals 184.5 over X.
45. 184.
184.5 over X.
I got it. 184.5 over X. All right. And then we're going to go ahead and solve that. So, Emmett, tell me how to solve that.
Would you multiply each side
By what?
by X?
Okay. So X will drop out. And then what are we typing in the calculator, Emmett?
You would write tan
I want to get X alone.
38. Would it be 184.5 divided by tan 38, or like vice versa? I forget which one exactly it is.
Divided by tangent 38, because you have this equation right here.
Oh, okay.
Trying to solve for X, right? So you would divide tangent 38 on both sides to get X in line. So 184.5 divided by tangent 38. 184.5 divided by tangent 38. And then again, it asks us to round to the nearest foot. So that would be approximately 236 feet is how far she is from the castle. And again, you want to pay attention at the beginning to round to the nearest foot. Sometimes students find it helpful to kind of go down to where the answer blank is and just kind of write like round to foot, just to help you remember that by the time you get to the end, you don't accidentally round to the wrong thing. Or also to maybe put the label there before you've even finished the problem. Okay, now I just want to talk about something that you may have noticed or you may not have noticed. What would be the angle measure of the angle up here? What would be this angle measure?
52.
Why, Riley?
Because we know that it's complementary to 38.
How do you know that?
Because there's a right angle and a triangle that is 180 degrees.
Okay, what did you say the measure was again?
52.
So that'll be 52 degrees because this angle and that angle have to be complementary, right? So if I wanted to use the 52 degree angle instead, so instead of doing tangent of 38, if I wanted to use the 52 degree angle, let me just move this out of the way a little bit here. Someone who has not answered a question today, tell me if you wanted to use the 52 degree angle, what would be an equation that would use the 52?
Couldn't you do opposite over adjacent? So you do, or I'm sorry. You do, wait.
You were right.
Yeah, you do tangent of 52.
Would equal what?
Hold on, my like split screen is like in like, okay, got it. You would do x tangent of 52 equals x over 184.5.
Okay. So then if we were solving that equation, Zach, tell me what we would do on both sides.
You would then multiply each side by 184.5, giving you 184.5 tan 52 equals x.
All right, now when we type that in, 184.5 tangent 52, same answer, right? Now the question that I have is, why do you get the same thing when you compare 184.5 divided by tangent 38 and 184.5 times the tangent of 52? Why do those give you the same answer? Help that make sense. Why is it that, because two people could do this problem differently, one uses 52 degrees and one uses 38 degrees and they get the same answer? Why is that happening?
Because the tangents of each of those angles are reciprocals of each other.
Why, Scott? What is it about those angles that tells you that they're reciprocals, the tangents are reciprocals?
Because they're the adjacent angles that aren't the right angle. And because they're complementary.
Complementary.
So
if
yeah.
If you haven't noticed that, I kind of told you it's probably better for you to use the angle that was given in the problem. But when you use the angle that's given in the problem, you end up with that variable in the bottom, and it's just a little bit more thinking. Like if you're Emmett, you're like, wait, I'm confused. Which way do I divide it? Well, you can avoid that by using the 52-degree angle. Okay. So if you want to think ahead for a second and be like, wait, I want to get the variable not in the denominator, which angle should I use? That's fine. Just be careful that you subtract, there, and don't make a mistake on the subtraction. Okay, so to kind of reiterate what Scott said, these will be the same. 184.5 times the tangent of 52 will be equal to 184.5 times the tangent of 52 will be equal to the 184.5 divided by the tangent of 38, because dividing by the tangent of 38 is the same thing as kind of saying like 1 over tangent of 38, and those are reciprocals of each other. We know that when you have complementary angle measures, they'll be reciprocals. The tangent of 52 is the reciprocal of tangent 38. So, again, you might do the problem, set up the problem differently than someone else, but as long as the picture is drawn correctly and you got your numbers in the right places, you get the same answer no matter which way you do it. So if that's not something you noticed before, just kind of wanted to point that out, that that's why you're getting the same answer with tangent 52 and tangent 38. Okay, and then the last problem, I cheated and copied a helicopter, because every time I draw a helicopter, it looks awful. So I copy and pasted. A search and rescue team is airlifting people from the scene of a boating accident. So we've got water down here. And the search and rescue team, they're going to drop a rescuer directly below. So they're going to let out a line here and drop directly below where they're hovering. So there's going to be a person down here that they are rescuing. And the distance, let's see, it says the helicopter is 18 feet above the water. So we know that the side of the triangle there is 18 feet. Okay, they see another person in need of help, and that person is not directly below them. So that person is like over here someplace. And so the triangle is going to look like this, looking down at that person. Here's your right triangle. Ew, doesn't look very right, but we'll pretend. Okay, so please get in the habit of putting the right angle mark there to indicate right triangles. So that's an 18-foot drop. And then it says the angle of depression this other person's 42 degrees. Frankie, tell me where to put the 42 degrees.
Like right under the helicopter, like on the helicopter.
So, oops, I'm going to move this 18 down here. You want me to put it right here?
Yeah.
Henry, tell him why that's wrong.
Oh, wait, I realize now.
Okay, Frankie, fix it.
So you have to draw a second horizontal line coming like off of where the helicopter is, kind of.
So why
And
is
then draw it on the outside of the triangle.
why is it wrong to use the one you initially said?
Because it's not equal to the angle of elevation.
Yes, it's always going to be from the horizontal. So if the people in the helicopter look straight out and then drop their eyes down to that person in the water, that should be the same angle as the person in the water looking up. If they were to look across the water and then raise their eyes to the helicopter, that is your angle of depression. Okay, and then it said that the helicopter's 18, no, it said that you're finding the horizontal distance from the rescuers to this person to the nearest foot. What is the horizontal distance from the rescuers to this person to the nearest foot? Anatier, tell me where the variable goes.
It goes at the bottom, on the bottom.
It's the horizontal distance, right? So that's the distance we're looking for, because they're not going to be able to rescue the person this way, right? We're trying to figure out how far are they going to have to fly over to be directly above this other person who needs help. All right, Kristen, tell me what to do next.
You need to figure out what the angle, the other angle is next to the 42-degree angle.
Okay, what will it be?
Like, sorry, let me get my calculator.
Okay, you don't have to find that angle. Can you tell me what this angle is?
It'll be 48.
Yeah, so the one up at the top is 48. What's the one at the bottom going to be, Kristen?
42 degrees.
42. So if you don't want to have to subtract it, just pull that angle of depression over, because the angle of depression and the angle of elevation should be the same. And again, it's just about perspective. People in the helicopter looking down at the person in the water, that angle measures the same as the person in the water looking up at the helicopter. If you want to use that angle up at the top, the one that Frankie initially told us was the angle of depression, but it's really not, you would just subtract from 90, and that would be 48 degrees. It doesn't matter which angle you use, just pay attention that you set up your equation correctly based on the angle measure you're using. Okay, so Peter, tell me sine, cosine, tangent, and what the equation would be.
I'm gonna use 48 degrees.
Okay.
And then it'll be tangent 48 equals x over 18.
So he's using 48, 18, and x. So tangent 48 is equal to x over 18. And then Allison, tell me what you do to solve for x.
You multiply both sides by 18.
Good. And then we're just multiplying that in the calculator. So 18 tangent of 48. And it said around the nearest foot. So what am I going to put as the answer? X is approximately what? Yeah, X is approximately 20. What's the label, Daniel?
20 feet.
20 feet. Now, again, you want to pay attention to the fact that it said nearest foot. Make sure you're rounding it correctly. Make sure there's labels on it. So again, at the beginning of doing the problem, you might want to jump down at the bottom, where you'll write your answer and kind of make yourself a note that it needs to be so many feet. You kind of make yourself an answer blank if there's not one there. So many feet and round 2 feet. Okay, just to kind of make sure that you don't forget to do that in the end.